Okay, we'll start today's lecture. That is today's Thursday, 27, 2020. In the previous lecture, what you are saying? Is it audible? Is it audible?
Yes, sir.
Okay. In the previous lecture, we have started the unit number 3, that is satellite link design. In that satellite link design, we have completed the first point, that is basic transmission theory. In that basic transmission theory, we have seen some of the parameters which is going to support a satellite system. And after that, we have seen one derivation. In that derivation, we have seen a number of equations. The equations is depends on the total power, received power, and you have calculated, you have seen the equation of effective isotropic radiated power, that is EIRP, and you have seen the gain of transmitter and gain of receiver. And one more equation we have seen, that is a path loss equation, that is LP. And after that, the combination of all these equations, and finally we get one equation, that is a total received power, that is PR. After all getting all these equations are normal equations, and that those normal equations are converting into the decibel equation. Decibel equations is nothing but we are just applying the logarithmic form. The logarithmic form can be applied to the specific equation. After applying that logarithmic application to the specific equation, you are getting that equation in decibel value. And you have seen in the previous class the equation of total received power with the flux density PR of D. I think you are written is equals to Pt into Gt divided by 4 pi d square. That is total, that is transmitted power into the transmitted gain divided by 4 pi, that is constant. The d is nothing but the distance between the transmitter and receiver. That is a power flux density equation. After that, the one more equation we have seen, that is effective isotropic radiated power, that is EIRP. The EIRP equation is mainly depends on the transmitted power into the transmitted gain, that is Pt into Gt. And after that, you have to calculate the particular gain of transmitter and the particular gain of receiver. While calculating the particular gain and particular gain of the transmitter and receiver, the equation is 4 pi AT divided by lambda square for transmitter gain. For receiver gain, that is VR is equals to 4 pi AR divided by lambda square. And this gain we have to calculate with respect to the receiver side. With respect to the receiver side, the receiver gain is equals to 4 pi AR divided by lambda square. We have to calculate this equation if you want to rearrange the equation with respect to effective aperture, that is aperture antenna, that is AR. If you want to calculate, we have to rearrange that equation. Whatever the effective aperture we are getting, that equation you are going to substitute in that particular the main equation. Finally, you are getting one equation with respect to the losses. Okay. And today we'll solve some of the numericals based on all these equations. If you are written, you can calculate it easily. See, the one more part is there in this converting all formulas into decibels. How to convert the all formulas into decibels? With respect to first equation, the power flux density, the PR of D is equals to ET divided by 4 pi d square. If there is a multiplication, you have to add. If there is a division, you have to make it negative, that is minus. So PR of D is also equals to psi is equals to 10 log of PT into GT. He has written directly. Instead of that, you can write 10 log of PT plus 10 log of GT minus 20 log. There is a D square is there minus 20 log of T plus minus it against it comes minus. So he has taken in bracket. So 10 log of 4 pi. So what is the power received by the antenna? That is PR is equals to PR of D into AR. You have seen that is AR. So if there is a multiplication, you have to make it addition. Same thing, the loss free space equation is LP is equals to 4 pi D divided by lambda bracket square. 4 pi D divided by lambda bracket square. If you want to convert this into the decibel value, so LP is equals to, that square is there, 20 log of 4 pi D divided by lambda. So what the total received power is, you have seen in the previously, same, this one, that is EIRP plus VR minus of LP. Same thing we are written. So PR is equals to EIRP plus VR minus of LP. So EIRP is equals to PT into GT. If you want to convert this into decibel, 10 log of PT plus 10 log of GT. So these are the sum of the equations for calculating, converting the normal equations into the decibel values. See, take this numerical first one. A satellite at a distance of 39,000 kilometers. A satellite at a distance of 39,000 kilometers from the Earth department radiates a power of 20 watts, an antenna with a gain of 22 dB, an antenna with a gain of 22 dB in the direction of VSAT at the Earth building with an effective aperture area of 10 meters square. I will explain this. I will just modify the equations. After that, you can calculate. Okay. The first, what you have to calculate, the find A, the flux density at the Earth station building, that is PR of D, you have to calculate. Flux density is nothing but the PR of D. Second, the power received by the VSAT antenna, that is total power you have to calculate. If the satellite, see, if the satellite operates at a frequency of 11 gigahertz and the Earth station antenna has a gain of 52.3 decibel dB, determine the received power. What he has given, all the values are in decibels. Okay, all the values are in decibels. If you want to convert that decibel into the normal value, so satellite antenna gain, the satellite antenna gain, that is 22 dB is there. You have to convert that decibel value into the normal value. So that becomes 10 log of GT, the transmitter gain, the satellite antenna gain, that is transmitter gain, that is you have to calculate transmitter gain is, he has given 22 dB. You have to convert that decibel value into normal value, that is 10 log of GT is equals to what? 22. So GT you have to calculate, that becomes NT log of 2.2. 10 becomes divided by 22 divided by 10, that is 2.2. NT log of 2.2 is 158.5 fat. But there is a, in the formula, there is a lambda. If there is a lambda, before that you have to calculate the wavelength. So wavelength equation is lambda is equals to P by F. So 3 into 10 raised to 8 divided by F. You have calculated, he has given F, that is frequencies of 11 gigahertz. See that, that is frequencies of 11 gigahertz. So you will get the equation, that is formula. The Earth station distance, that is D. That is D is given 39,000 kilometers. So 39,000 kilometers into meter, that is into 10 raised to 3. 3 into 3, that is becomes 3.7 or 39 into 10 raised to 6 otherwise. 3.9 into 10 raised to 7 meters. First you have to calculate the A, that is a power flux density. Power flux density equation is PT into GT divided by 4 pi D square. What is the transmitted power he has given? 20 watt. It is in watt, one is in dB. So you have to convert that decibel value into watt. First, see, listen here. You have to convert that decibel value into the watt. Okay. So one is in watt, one is in dB. So we have to convert that into a watt. So 20, that is transmitted power, into you have converted the GT value, that is decibel value, into the normal value. So 158.5 watt divided by 4 pi into the D is 3.9 into 10 raised to 7 whole square. You will get the PRD, that is power flux density. Similarly, if we ask to convert the particular equation, convert the particular value into the decibel value, what it becomes? You have seen the formula, that is 10 log of PTGT minus 20 log of T plus 10 log of 4 pi. That value is decibel value. Otherwise, you have to convert directly whatever the value you are getting, or converting to decibel, that is 10 log of 1.66 into 10 raised to minus of 20. Instead of all the theoretical, you have to make it only one formula, that is 10 log of 1.66 into 10 raised to minus of 13. You will get the directly decibel value. This is a A. Similarly, for B, what he is asking, the power received by the VSAT, the total power received. Total power received equation is what? PR is equals to PR of D into AR. You have already calculated the PR of D into, instead of AR or AE. AE, how much he has given? That is of 10 here. The VSAT at the earth building with the effective aperture, that is AR, area is 10 meters square. You'll get directly, you'll get the power received with the effective collecting antenna, that is PR is 1.66 into 10 raised to minus of 7. Next, third one, what is asked? In decibel, you have to convert it directly, that is convert it directly. If the satellite operating frequency, you have to calculate the received power, and working in decibels, the path loss equation is what? Path loss equation you have to calculate, because he has asked determine the received power in decibels. So decibel value is what? The EIRP plus GR minus of LP. So LP is there, you don't know LP, that is path loss. You have to calculate this path loss by using this formula. LP is equals to 20 log of 4 pi d divided by lambda. So substitute all the values in this, you will get the LP, that is path loss. You don't know EIRP, so calculate EIRP. EIRP is equals to PT into GT. GT is already in decibel. GT is already in decibel. No need to convert. But PT is in watt. PT is in watt. So you have to convert. There is 10 log of 20. 10 log of 20. You will get EIRP. So whatever the values you get, substitute those values in this formula. EIRP is 35.01. Receiver gain, that is he has given, I think, receiver gain is 52 point. Here it is. The antenna has a gain of 52.3 dB. 52.3 minus LP you are calculating, that is path loss, that is 20.508. So the total received power is of minus 117.77 decibel. Similarly, you have to calculate one more numerical and tell me the answer. Okay. Take a satellite at a distance of 45,000 kilometers, 45,000 kilometers from the department building, radiates a power of 35 watt, radiates a power of 35 watt from an antenna with a gain of 44 dB, with a gain of 44 dB in the direction of a VSAT at the earth building with an effective aperture area of 20 meters square, 20 meters square. Similarly, you have to calculate all this. A, calculate the flux density at the earth station building, that is K. Here of D, you have to calculate. Second, the power received by the VSAT antenna. power received by the VSAT antenna. And C, if the satellite operates at a frequency of if the satellite operates at a frequency of 25 gigahertz 25 gigahertz and the earth station antenna has a gain of earth station antenna has a gain of 45.5 dB. Earth station antenna has a gain of 45.5 dB. Determine the received power. Determine the received power. What he has given? The total distance is of 45,000 and 35 watt he has given. 35 watt, that is of GT, and 44 dB, that is of PT. 44 dB, that is of PT, and aperture antenna, that is AR or AE, that is of 20 meter square, 20, that is 20 meter square, and he has given a frequency, that is F 25 gigahertz. F he has given, that is 25 gigahertz, and GR he has given, that is of 45.5 dB. 45.5 dB. Calculate. Tell me the answer. I will give you 5 minutes. Apply the same. First, you have to convert that antenna again, that is of 35 watt, that is 44 dB into the watt, that is GT. After that, you have to calculate the wavelength lambda. Lambda you have to calculate. A distance he has given 45,000 kilometers. And you have to calculate the total received power, that is with a plus density, that is PR of D. PR of D. PR of D. Do it. Can you tell me the value of GT? After converting the decibel value of 44 dB, decibel value into the watt, GT value. I think everyone is solving. What is the value of GT? 10 log of GT is equals to 44. 10 log of GT is equals to 44. So GT is how much? Antilog of 4.4. Antilog of 4.4. What is the value? Anyone? Respond fast. What is the value of GT? Hello? Hello? Is it audible? Hello? Hello? Hello, Ashwini.
Yes, sir.
What is the value? How calculated?
25,118.86.
25,000. Why? Antilog of 4.4.
Yes.
Anyone apart from Ashwini? How much is the value? What is the value? Komal, Deepika, Janvi. Is it right? Donore, Priti Godse, Vaishnavi Korpe. Pass. Respond. What is peer of D? Peer of D. What is peer of D? See the screen and calculate. Rutuja Chauhan, A division. Rutuja Chauhan.
Yes, sir.
Now, what is the peer of D value? Have you calculated?
No, sir.
Why?
Sir, my calc is not with me.
Where is it?
Hostel, sir. I forgot that.
Then you have to take some others. No?
Yes, sir. Sorry.
Sureka, Gunjan, Sureka, Gunjan, Abhilasha, Kale, Komal, Kale, who has calculated? Who has calculated? Give me the response. Hello. Calculator is not available. This is not the reason. Okay. Keep in mind. You have to arrange something. Anyone from boys side? Boys, who has calculated? The last lecture, the response is good. Well calculated numerical. What happened for this time? Boys, Muske, Web Sheikh, Nitin Pandre, Samir Patan, Shubham Ghodke. Respond fast. Okay, Ashwini, what is the value? No one is responding.
PRD 3.45 into 10 raised to minus 11.
3.4 into 10 raised to minus 11. Okay. Next. Converting into
And
decimal.
minus
Converting
104.61 dB.
61 dB. Okay. Total
Minus
power is
that I have
PR.
not calculated.
Calculate.
Okay.
Ashwini from A division CR.
Yes, sir.
What is the value of PR of D? Have you calculated?
Yes, sir.
What is the value?
Minus 104.61 dB.
What is PR of D without the decimal?
3.4 into 10 raised to minus 11.
Okay, good. Okay. Calculate next TIRP, that is power received PR. After calculating PR, you have to go through this, the path loss, that is LP. So out of 82, only 2 are responding.
Sir, PR is 6.9 into 10 raised to minus 10.
10 raised to minus 10. Okay.
Yes.
Calculate LP. LP and PR last. Boys side, getting the answers. Boys. Anyone from boys? बॉयज है ना इसमें? अनम्यूट करा। किरण पाटिल, किरण पाटिल आहे का? किरण पाटिल इज देयर. संतोष उबाळे, सुशांत
Sir,
हलदार.
LP is sir
हा बोला.
LP is 213.46 dB.
ओके. कॅल्क्युलेट पीआर. स्वप्नील दर्शनले, विशाल पाटिल, ओंकार साळुंके. सर जो कर रहे हो बस अंत करना है. करा फास्ट. Only one is responding, that is Ashwini. What about others? देवकते, गायत्री, गायत्री देवकते. No.
Yes,
हाँ. Calculated.
no, sir.
Why?
Sir, I haven't written question.
हाँ.
Question ही नहीं लिख लिया sir.
क्यों? ऐसे मत करो.
Okay, sorry.
What about remaining? Calculated. Ashwini. What is the answer, Anshini? PR?
Sorry, ELP is 230.6 dB.
PR? PR, EIRP plus GR minus of LP. GR is, he has given 45.5. LP has calculated 213.46. 213.46. And EIRP, you have to calculate EIRP is equals to PT into GT. PT has given in watt, that is 35. 10 log of 35 plus GT is 44. 10 log of 35 plus 44. You will get the value of EIRP. Calculate the total received power, that is PR. PR equals to EIRP plus GR minus of LP. Tell me the value.
Minus 108.52.
Okay, minus 108.52 decibel watt. Okay. So this is not the good response. Huh? Only one or two are responding, others remaining are quiet. So tomorrow onwards, you have to respond immediately. You have to respond immediately. Keep in mind.
Okay, sir.
You don't have calci, sir. I don't have calci. You have to arrange something, no? In the online, they are going to calculate. You are going to complete the syllabus minimum 3 to 4 units, 3 to 4 chapters. If you are active, you are concentrating in each and every lecture, then only you are understand. Otherwise, just for the sake of attendance, you are attending. That is not a good. Okay, next. We'll see the next. Tomorrow, everyone has to respond. I will ask, keep in mind, I will ask you the equations. You have to be ready with your calculator. This numerical is totally a numerical part. You have to solve maximum numerical. The range between a ground station and a satellite, the range between a ground station and a satellite is 42,000. Is 42,000 kilometers. Calculate the free space loss, a frequency of 6 gigahertz. Range between a ground station and a satellite is 42,000 kilometers. He has given the distance D. Calculate a free space loss. That is nothing but you have to calculate LP. You have to calculate LP has a frequency of 6 gigahertz. So what he has given? He has given the distance D, that is 42,000 kilometers. You have to convert that into the meter, or if you want to keep it as it is, you can keep it. The frequency has given 6 gigahertz, that is 6 into 10 raised to 9. The equation of the path loss is directly as converting that into decibel, that is 20 log. The LP equation is what? 4 pi d divided by lambda bracket square. The normal equation without the decibel equation. Okay. That is path loss is 4 pi d divided by lambda whole square. That equation is converted into decibel, that becomes 20 log of 4 pi divided by lambda. You don't know lambda. First, you have to calculate the value of lambda. So, lambda is equal to what? C by F. You know C, that is 3 into 10 raised to 8. He has given the frequency F, that is F is equal to 6 gigahertz. So, 6 into 10 raised to 9. You get the value of lambda, that is 0.05. All the values he has given, you have calculated the value, lambda value. Finally, you have to calculate the path loss, that is LP. So, LP is equal to what? 20 log 4 pi d divided by lambda. So, 20 log 4 pi d has given, that is 4.2 into 10 raised to 7. You have calculated the lambda value, that is divided by 0.05. Using your calculation, calci, the final path loss is 200.46 dB. This is how to calculate the path loss. This is how to calculate the path loss. The MCQ questions he may ask for 1 mark, that is for calculating the path loss. Okay, take one as a homework. Take one as a homework. The homework is write down the range between. I will give only one the question as a homework. That is, you will get max 2 minutes or 5 minutes. The range between a ground station, and a satellite is 36,500 kilometers. The range between a ground station and a satellite is 36,500 kilometers. 36500 kilometers. Calculate the free space loss, that is LP. Calculate the free space loss as a frequency of 12 gigahertz. Calculate the free space loss as a frequency of 12 gigahertz. Take this as a homework. Tomorrow I will ask you the equations and this numerical. Okay. In the timetable, they have added the tutorial. In that tutorial, you have to be ready for one topic. For one topic, you have to explain. You can choose any one topic. You have to explain, that is in 5 to 10 minutes. Take any topic from unit number 1 and unit number 2. That is left to you. Everyone at the time of tutorial, that is on Saturday, you have to explain any one topic. You can take any topic from unit number 1 or unit number 2. Be ready on Saturday. The tutorial, you have to explain it in 5 or in 10 minutes. I will ask you anyone, you have to respond it. So prepare on Saturday. You have to explain any point on unit number 1 and unit number 2 only at the time of tutorial. Every Saturday there is a tutorial. You have to choose one topic. You have to just justify what you have understood and tell me about that point in 5 to 10 minutes. How much you understood, that much you should tell. I am there to help you. Okay? Got it? Okay. Today we'll stop here. Be ready for any of the topics for getting the seminar. Everyone has to give your attendance. And before 5 minutes, you have to join for the Python training.